So today we'll be looking into how we could take an Bayesian approach to the modern portfolio theory. The modern portfolio theory, also known as the Markowitz modern portfolio theory, is a quantitative method used by investors to maximize an investment's reward based on its risk. The concept of modern portfolio theory is that it does not take into account an investor's view, where in practice an investment manager's view on a specific sector or industry would affect the weighting on the individual assets within a portfolio. The Black-Litterman model takes a quantitative approach to solve this problem by applying Bayesian statistics in the model. The Black-Litterman model takes the prior, which is the investor's view, and two different matrices, the P matrix and the Q matrix, and the posterior is a vector of new expected returns. As for the portfolio that we'll have, it will consist of the following securities, which are industry specific. It will consist of real estate, industrials, semiconductor, energy, consumer staples, and utilities and healthcare industry-specific ETFs. And the assumption is that given the current news, I'm interested in specifically real estate, semiconductors, and consumer staples. And so I will obtain the industry views specifically for the said industries. These are the variables in question. And for the investor's view specifically, we'll be taking a hierarchical approach to it. We'll create a data table consisting of top 10 assets in each industry ETF, and the columns will consist of the assets industry as a numerical representation, 7 in total. The ratings would be from the S&P Capital IQ consensus estimate reports, and the JAX code J will represent industry and I will represent the rating. This is just an example of the hierarchical approach that we'll be taking. This would be the posterior expected returns and new weights calculation using the Black-Litterman model. This is just the data that we've collected for each ETF and also the industry-specific assets grouped numerically 1 through 7. This is the results from our hierarchical model, and we'll be focusing on the mu-J's related to the semiconductor, real estate, and the consumer staple industries. Giving it into the Black-Litterman model, we see that we have a newly combined return, an implied equilibrium return, which then we have the return vector differences. From the new combined return, we calculate the new weights compared to the market capitalization weights, and we see that in the weight difference column, that only the assets or the ETFs that we had certain views on were affected, whereas the other assets were not impacted in its weightings. The new weights sum up to 103%, which is greater than 100%, of course, but this is pretty common in the mean variance optimization that the Black-Litterman model also uses. Weights well over 100% implies leverage, which means buying the stock on borrowed money for greater returns. That is it for the introduction, and thank you.